Biochemical Oxygen Demand, or BOD, measures the amount of dissolved oxygen that aerobic bacteria need to break down organic matter in a wastewater sample. This metric serves as both a strict legal requirement for environmental compliance and an essential diagnostic tool for running treatment plants. We are going to walk through the exact procedures to run this test. You will learn how to prepare the dilution samples, measure the dissolved oxygen correctly, and calculate the final metric in milligrams per liter. Before starting, you need your equipment ready on the bench. You'll need a BOD incubator to hold specific temperatures, standard 300 milliliter glass bottles, a dissolved oxygen meter, and the necessary chemical nutrients. The bacteria in this test are highly sensitive to their environment. Failing to strictly follow these preparation protocols will skew the data, resulting in either a failed compliance report or incorrect adjustments on the plant floor. Step 1 is preparing the dilution water, which will serve as the baseline environment for our sample. Take standard distilled water and add a specific combination of essential nutrients: phosphate buffer, magnesium sulfate, calcium chloride, and iron chloride. Once the nutrients are in, aerate the mixture vigorously. The aerobic bacteria require an environment completely saturated with oxygen to survive and process the waste. For step 2, take a measured quantity of your raw wastewater, usually between 1 and 5% of the total volume, and mix it directly into the dilution water inside the 300 milliliter bottle. Immediately place your DO meter into the bottle to take your initial dissolved oxygen reading. Record this specific value as variable D1. The moment you capture D1, seal the bottle completely airtight. If any external air leaks into the bottle during the test, it provides unaccounted oxygen to the bacteria and ruins the measurement. Securing an accurate D1 reading and locking down that airtight seal establishes the baseline we need to track exactly how much oxygen the bacteria deplete. Now we move to step 3, incubation. At this point, the protocol splits into 2 distinct paths, depending on what you need the data to accomplish. This diagram outlines 2 incubation paths. Path A, on the left, takes 5 days at 20 degrees Celsius for official legal compliance reporting. Path B, on the right, takes 3 days at 27 degrees Celsius, providing faster feedback to adjust internal plant operations. The choice of protocol relies purely on your immediate operational needs: waiting for the legal compliance standard, or speeding up the chemistry for rapid internal adjustments. For step 4, return to the dark incubator once your chosen timeframe has elapsed and remove the bottle. Carefully break the airtight seal and prepare to measure the remaining dissolved oxygen inside the sample. The aerobic bacteria have spent the duration of the incubation breaking down the organic matter, actively consuming the dissolved oxygen as they work. Read the meter. Because the bacteria consumed oxygen, this new number will be significantly lower than your initial baseline. You will record this reading as variable D2. We now advance to step 5. You have captured the physical variables, but the raw D1 and D2 readings are incomplete until we apply them to the SEMTA mathematical formula. Taking precise laboratory measurements sets up the variables, but the true pollution level of the wastewater is only revealed through the calculation phase. Look at this formula on screen, representing the dilution factor, known as variable P. It measures the ratio of your raw wastewater relative to the total volume in the bottle. If you started with 15 milliliters of wastewater in a standard 300 milliliter bottle, P equals 15 divided by 300. That gives a dilution factor of 0.05. Now we view the master calculation. We subtract the final oxygen reading, D2, from the initial reading, D1, and then divide that result by our dilution factor, P. Let's run a hypothetical set of variables. If your initial DO was 8.5 and it dropped to 3.5, the difference is 5. We take that 5 and divide it by our dilution factor of 0.05. The equation resolves to 100. This metric is expressed as milligrams per liter. The calculation factors in the dilution, defining the biological depletion as a specific ratio of the sample size. There is a mathematical conversion available if you make an incubation error. If you mistakenly run a 3-day test at the cooler 20-degree temperature, the bacteria only consume about 65% of the organic matter. You can divide your result by 0.65 to estimate the standard 5-day value. With the math finished, route the resulting data to its proper destination. File the 5-day numbers through official compliance channels, or use the 3-day results to immediately adjust your plant parameters. You must watch out for toxicity. If heavy metals or toxic chemicals are present in the raw water, they will kill the aerobic bacteria. Dead bacteria cannot consume oxygen, which leaves you with a falsely high oxygen reading and an artificially low BOD result. If you suspect your wastewater contains non-biodegradable waste or heavy toxins, this protocol will not work. You will need to conduct a chemical oxygen demand test instead. By accurately preparing the dilution, securing an airtight seal, and performing the correct math, you produce the reliable metrics required to meet legal environmental standards while maintaining plant efficiency.